So far regarding a sample and define those for population. So I will start, the book starts with the population mean. I'm going to just go a step back first. I'm going to define capital N as the sample size. No, sorry, population size. Population size. We talked about it, right? So what is the population size of United States? That's census, right? It's all of the United States citizen, right? And now we can talk about population mean. Population mean, you know what this means. It's the average, the same like sample one, except it's population mean. And we are using a different variable now. We are going to use the variable Greek letter mu. So mu is equal to sum of all observations divided by the population size. Please recall sample, mean, and see it's the same thing with different values. I mean different letters inside, right? So population mean is mu equals sum of all xi's divided by the population size. Population standard deviation has similar formula. So population standard deviation is, instead of using S, is using sigma, another Greek letter. So it's sigma. It's like the O with a little wee. Right, it's sigma. Could be. 6 goes this way. If you curve it that way, yeah. In calculus, we will say concave up instead of concave down. So we will have the formula that says summation of xi's minus the mean, but now we are using mu because we are a sample. And if you remember, if you learned your formula for standard deviation, you know that the sample had n minus 1. This one just has n. There's also alternate formula. Sigma equals square root of sum of all xi squared divided by n minus mu squared. That's the alternate formula. All the calculations are the same as before. We'll obviously do the example, but and the last thing that it's completely new, you haven't seen before, is going to be the standardized variable. Z is equal to x minus mu over sigma. I will explain this as we go along. So each xi, each observation has its own z. Now we'll talk about what this means. Now I would like to get a population data and work on all of these concepts that will make sense. So here's some, I'm just going to pick up whatever numbers. So this is the population data. We don't even care what they represent, it's just numbers so we can go through our calculations. So the data is given as 5, 24, 20, 26, and 14. That's the data. Let's find the mean. The mean is equal to sum of all observations divided by how many there are. So that's 5 plus 24 plus 20 plus 26 plus 14 divided by 5. This is, ooh, nice. No, it's 24 over there, really? All right. So that's 40, 60, 80, 89 divided by 5. So 89 divided by 5 is 90 divided by 5. It's 9, so 18.5, right? 17.75. 5 8, yes. Yes. The fifths, oh my god, 0.2, 0.4, 0.6, no, I give up. So we have the mean. Mu equals 17.8. That's what it is. 17.8. That's mu. Mean. Population mean. Population mean. The next in line for us to find is the standard deviation. So to find standard deviation, we are using our formula. Sigma equals square root of summation of all xi minus mu squared divided by capital N. We remember that we need to create a chart of values. 5, 24, 20, 26, and 14. You only need to put the data in increasing order if you're looking for median and quartiles and things like that. But mean and standard deviation, these scores, they don't care about order. So these are your xi's. You are supposed to now subtract the mean from each one of these. So every number minus 17.5, so that's negative 17.8. So negative 12.8. 24, that's what? That's 6.2. And then 20 is 2.2. And 26, 8.2. And 14 is negative 3.8. Everyone happy? With a smile? All right, 3 people, thank you. The rest of you, not so much. We are going to square each one of these now. Xi minus mu squared. So we are squaring each one of these numbers. So 12.8 squared is 163.8. And then we have 6.2 squared. 38.4. 2.2 squared is 8.2 squared. 67.2. And 3.8 squared. 14.4. Now we're supposed to add all of these numbers because there is a sum in the formula. So we are adding all of this. No, that's 6. 288.6. So now the standard deviation is the square root of 288.6 divided by, and we had 5 entries, so we are not subtracting 1 for population. So this is the square root of 55.72, let's say. 5572. Yes?
What was the reason we subtracted 1 from the previous problem?
I'll explain that. That's the difference between these. And then the square root of 55.72 is about 6 point something. No, 7 point something.
288.6 divided by 5, I got 57.72.
Oh, yeah, 57.72. Okay. And then the square root of that is about what?
7.5.
7.6 when you round. Yeah, 7.6. Great. So now we have population standard deviation given. The reason is, so why do we have -1 for the sample and we don't have -1 for population? So population has all of the data points, so we are using all of the data points. Now for the sample, you take some. And in certain cases, when you are using the size of the sample, the number that you get actually overshoots the actual variance. So when you subtract 1, the results are much better. And on average, right, it gives the correct result. So for sample, we have n-1. For population, we have capital N. That's that. I just want to find one of these z values. So let's say find z for observation x equals 20. Well, z equals 20 minus 17.8 divided by 7.6, because it is x minus mu, observation minus mu over standard deviation. And we get 2.2 divided by 7.6, we get 0.3, right? Something. 2.2 divided by 7.6.
0.29.
0.29. Good. They said about 3.3. Good. That's that. Now, the meaning of this number, again, we'll do more examples next class. This observation, 20, is 0.29 standard deviations away from the mean, to the right. But we'll do that interpretation next class. Yes? There's no formula sheets. What are you learning? Statistics. What statistics? Formula. Oh. For the moment, you got me concerned there. All right. Bye, everybody. So one more example next class.